Okay, whatever you find it to be, you're going to plug that back into your original equation. So again, we can use our calculators here. So if we took x squared minus 2x plus 1, and we wanted to evaluate it with x equaling 1, we get our y-coordinate to be 0. So our vertex is going to be at the point 1, 0. Okay, so right now, just with this, the information that you know about this graph is 1, 0 is our vertex. Is the graph opening up or down? We already determined it's opening up. So when you label your vertex, label it opposite the direction that it opens. So if it opens up, we're going to label our vertex 1, 0 down here, because we know our graph is going to open up like this. Okay. If we needed to sketch the axis of symmetry, that's embedded within this step. The axis of symmetry is simply x equals whatever that x coordinate is. And so right here is the example of our axis of symmetry. It's just a vertical line through the vertex. And the graph is symmetric on either side of it. It's a mirror image on the left and the right. Okay, there's two more things that you need to be able to do with this graph. The first is find the Y-intercept. Okay, so to find a Y-intercept, what do you think you're going to do? The Y-intercept occurs when the x-coordinate is equal to what? 0. So simply plug in 0 for the x-coordinate. So if we take this function again that we have here, change and evaluate that whole function for 0. So x squared minus 2x plus 1 equals 0. And the easiest thing to think about this, we can plot this point 0, 1 on the graph as well. But when you look at this, when x is 0, your y-intercept is going to wind up being this value right here, right? It's always going to be this constant. Whatever the constant is in standard form, right here is going to be your y-intercept. Okay, so it's the point 0, 1 for this graph. Okay, and there's one last question I'm going to ask you regarding these types of problems, and that is I'm going to ask you to pick a point that lies on this graph. So pick any other point that lies on the graph beside the vertex and the y-intercept. How do you think you might go about finding another point? Any ideas? Okay. So what? Okay, so if you know, so one thing is you can use the idea of symmetry, which you guys will be doing in a few years in Algebra 2. But if you go up 1 and over 1 to get to this point, what do you think you're going to do to get to this matching mirrored point on the other side? You're going to go up 1 over 1 more. So that means this new x-coordinate is 2 and the y-coordinate is 1. So you could do that. That's a nice, easy way to find it. Okay. Now the other thing that you could do, since we've already entered our calculator like this, Becca? Did you have a question or an idea?
But from the very start.
Okay, so if we wanted to, we evaluated when x was 1, we evaluated when x was 0. We could pick any other point to put in here, right? What if we evaluated for x of 2? And hit enter, what should we get? 1, and let's see if we do. Yes. So what you could do if you set it up this way with the evaluate key, the with key, just pick any other point. And you will find what the corresponding coordinate is. Okay.
I lost you when you had the y equals x squared minus that first part.
Okay.
How did you get to the bottom equation where it says under the A1, B2, C? How did you get from there to there?
Right here.
Yeah.
So I'm trying to color code the steps. So this step right here, this blue step, where you identify your A, B, C values is how you find the vertex. So on this one, we're finding what the x-coordinate of the vertex is using, oops. So we were using this step right here. Negative b over 2a is what we used to find that. Okay, let me go through the whole process again. And I just wanted to give you time to kind of write out the steps here before I go through another problem. All right, let's say I have the following equation. Y is equal to x squared. Yeah, we'll go negative x squared plus 2x minus 3.